It's live.
Yeah. Yes. Good evening. Good evening, students. How are you all? Yes. Uh, are you all fine? Great. So, am I audible clearly? And my visibility is that clear? So, just before we started, let us fix all these. Hope my voice and my picture is clear to you. Okay, whatever I'm explaining to you is very clear, right? Great. Yes. So, how was your day today? Sunday, enjoyed a lot. Great, fine. Okay, so are you excited for today's session? This today's scientific talk. What are we gonna talk, and how is that gonna take our range from what position to what position, right? So definitely this talk will be like so engaging, and you will be knowing much more about the cosmos, much more about the universe, and all its secrets also. Okay. It's actually the topic is about the evolution. How did the universe evolve? Okay, so how did the universe started its journey and how it is going on until when it will be traveling still? Okay, yes. So the topic is about the Big Bang, right? So it is about the Big Bang. So most of you might have heard about this Big Bang, right? So might have heard about the Big Bang theory. What is exactly a Big Bang theory? And there are many contradictions about this theory, but astronomers, the space scientists, were able to find it very clearly that this is the theory which they have predicted, like how was the universe formed and how did it evolve. Okay. Now, let me share my screen quickly and then let me explain you that. Give me a tiny second. Yes. So this is how the universe goes on. So hope you can see my screen, right? Yes. Fine. The Big Bang. So in this Big Bang, normally what happens is this explains about how was the universe started its journey. How did the universe started its journey? Okay. Now this is like a big question to each and everyone. So most of the people think that uh, this Big Bang will be starting from a black hole singularity. So if you have studied about the black hole has different parts, right? Now it is been already explained, like you already might have know that whatever comes closer to the black hole, it sucks the data, it sucks that light, or it sucks that object, and it makes that object to fall in the single point called singularity. Even this Big Bang had started from the same singularity. Okay, but they don't have any connections. Okay, both the points are singularities, but black hole and the Big Bang don't have any connections. Okay, so even the astronomers were have believed this was in ancient time, like in the past, but the scientific proof have led them that Big Bang and the black hole don't have any connections. Okay, so the Big Bang is only about how did the universe started its journey and how is that evolving now. Okay, so when did this happen? This happened a great long back time. Now, when we are talking about our solar system, which was just formed before 4.5 billion years, approximately something close to 5 billion years. Okay. But when did the Big Bang happen? It is almost all 13.8 billion years back. Okay. 13.8 billion years back. Now it's like so huge time, right? And after that, after 13.8 billion years, now see, our solar system was formed only 4.5 years back. For approximately 8 to 9 billion years, there was nothing. Like there was something like stars have been taken birth, and then the galaxies were formed. But it took a lots of time, a huge time. Okay. So in this, we'll study about each and everything very clearly. Okay. Now, actually, when you're studying about the universe, when you're talking about the universe, uh, how do we start it? Now, our first question will be, what is the composition of the universe? What does the universe contain? So this will be our first question, right? Okay. Now, what will you answer? Let me see your answers in the chats. Let me see your answers, all your answers in the chats. Yes. Let me know, what does the universe consist of? Yeah. Okay. Now, what does the universe consist of is whatever we are able to see in the universe. Whatever we are able to see. Now, if you go out, you are seeing the night sky. It's filled with a complete, a huge amount of stars, right? If you go to a rural area or a hill station, now you can see, you can even point your telescopes to the galaxies also. Yes, even the galaxies are also a part of universe, right? So whatever we are seeing, the whatever the observable universe which we are seeing is a part of the universe. So what does that include? It includes the stars, it includes the planets, it includes the galaxies, it includes the exoplanets, right? It includes clusters, it includes the super clusters, right? It includes the black holes, neutron stars, pulsars, magnetars, everything. And beyond that, it also includes a huge amount of gas, dust, and the entire space which we are able to see very clearly, right? So you can see this one, a tiny patch of the sky contains thousands of galaxies over here. Like not one single. We think that the galaxies are very fewer in number, like very less in number, but not. In a galaxy, it might be 200 to 400 billion stars. But in a cluster of galaxies, there will be more than 100 million galaxies. So there's a huge number. Right. So we aren't aware of all these galaxies. We are very, very, very closely aware of a galaxy which is very close to us, which we are living. One is Milky Way, and which is very close to us, that is Andromeda. We are aware of only one or two, or like if we count that in a hand, so it will be like a 10 to 15 galaxies that we are aware of. But if you go beyond that, each and every dot where you see in the deeper space is a galaxy. And think that that galaxy also contains plenty of stars, right? So it contains plenty of stars, it contains dust, gas, it might have a black hole inside it. Okay, there might be a new star formation happening. So everything is been included there, right? Yes. Did the universe always look like this when it was started? Did the universe, now we are seeing a different universe, right? Yes, we are seeing a different universe. Like we are seeing plenty of stars, and we were able to find a huge gap between them. Right now, if you talk about the solar system, now if you take the sun and the earth, they are separated by a distance of 150 million kilometers. And earth and moon, they are separated by a distance of 3,84,400 kilometers, right? Similar to all that planets, if you consider their distances, like they are very far away, right? Now, my question is the universe same which it is now? Was the universe same which you are seeing now? Was the same in the past also? Yes? Did the universe always look like same or look like this which you are currently seeing? No, right? Definitely no. Definitely no. But why? Definitely no. But why? What is the reason behind it? What is the reason behind it? The reason is the universe is continuously expanding. The universe is continuously expanding without any limit. Now, when the astronomers were studying about this Big Bang, when they were studying about this Big Bang, they never thought that they could be see this universe. Okay, when they saw that, okay, they thought that okay, this universe will be the constant, and there would be no change in the universe. And this is what we are going to see throughout its evolution. But after few years, but what happened to the astronomers after few years? It was like the universe started expanding rapidly. There was a huge gap created between the galaxies. Now, first they observed few galaxies, they were very close to each other. But later on, what happened? Those galaxies were moving apart. But how were they moving? They were actually not moving clearly. But the universe, the space around them, the universe around them is moving. So, how could we do this one? Like, supposing that if your mom is making a cake, okay, she mixes up all the dog nut, okay, and then she just puts up the raisins and sprinkles it over at some different positions. When she bakes the cake, when she bakes the cake, now see at that position, what happens when you take a photo of the raisins, when you just, I mean, drop them, now they will be at very closer distances, right? After that, what it happens when the cake is completely baked? Now you see that the raisins are not at the same distance. The raisins are not at the same distance. They are separated by a huge distance. Did the raisins really moved apart? When you have put that cake in the microwave, so did that raisins moved apart? Obviously not, right? Definitely it didn't move out, right? Then what did it move? The dog which was baking, right? The dog which we used for baking, the mixture of atta and everything, what we have used, so that expands. And when that expands, it also takes out the raisins and it moves apart. It moves apart. Okay. Now, this is how the universe is expanding, and it is still doing that even now, also. Okay. Got it? Okay. So, for this, we'll do a small experiment for this. So, have you got your balloons, everyone? Have you got your balloons? Yes or no? Have you got your balloons? Just let me know in the chat if you have got the balloons, yes or no. I guess you were asked to get a balloon and a marker and then a scale, a ruler, right? Let me know if you have got all that. Yes. Okay. So fine. We'll do one thing now here. So let me come and share it again. Now, what are we gonna do is before inflating our balloon, so with your marker, kindly draw some circles on the balloon. Okay, kindly draw some circles on the balloon. at different positions, like 5 or 6 balloons, six patches like this. You can just put 6 or 7 dots like this, which are being shown here before inflating the balloon. And you can even draw a light wave like this in the form of a wave like this. Okay, so try doing that. Yes, so something like this, a patch like this, a patch like this, and a patch like this. Okay, after that, a wave like something like this. Okay, now if you are done, now what are you gonna do is you are gonna find the distance between this one and this point. These 2 points, which are known as crest, CREST. So in a wave from one wave to another wave, it is called crest. So from here to here, just calculate the distance with the help of a ruler. Okay, hope you're understanding this one, right? Yes. So what are we gonna do? So after drawing all this, now you are gonna calculate the distance from this central part of this wave, which is a crest, to one more crest. Okay, at here, and just calculate this distance. What is this distance? Okay. Now, if this is done, if this is done, now inflate your balloons. Just blow your balloons. Now blow your balloons, and after blowing a certain extent, and please stop blowing now. Just hold the mouth tightly so that the air doesn't goes out. Okay. Now here, what are you gonna do is again calculate the distance between these 2 points. The points which you have already calculated, again calculate the distance between that 2 points and note down it separately. Yes. So initially it will suppose that if it is like 1 centimeter initially, and when you inflate it, when you blow the balloon, now it will be something around 3 to 4 or 4 to 5 centimeters. Okay. Now it means that the light which is approaching you is stretching. It's not coming in a closed wave like the initial one. It is stretching. And you can also see the points which you have drawn here, the points which you have drawn here. Now, these are also apart. Now, they are separated apart. They are not very close to each other like this. If you can see here, if you can calculate the distance between them, it will be very small. But if you are trying to calculate the distance over these 2 points, now you can see that these two are very far apart. Yes. After that, now think that this is your primary patch. Like this is your reference frame. Okay, you are in reference with this body. Okay. Now what happens? Now you can see that everything from you are moving away from you. Every patch which is away from you is nothing but they are moving away from you. Okay, so this was how the expansion of universe was confirmed, but not exactly in this manner. This is an experiment to understand it very clearly. But there was a famous astronomer called Edwin Hubble. He was very passionate about studying the galaxies. So when he was watching the galaxies with his telescope, now he could see that these galaxies which are very close to us, now they were moving a bit with lesser speeds, but the galaxies which are apart from us, like very far away from us, they are moving with a greater velocities, greater speeds. Now that statement confirmed that universe is expanding very rapidly. Like it's moving like a swift. Okay, is that clear? Hope you understood this one. Okay. So first thing what you have to do is have to take the balloon, just put some patches on it, and then draw a wave. Okay, and take all the measurements here, distance between the patches and the distance of the crest. Okay, or even trough also fine. Even this point also will be fine. And after that, inflate your balloon, and similarly now calculate the distance between the same points which you have already done. Okay, now you could find the difference. This difference is nothing but how it shows that how the universe is expanding rapidly. Yeah, okay? Yes, once again. Yeah, just give me a moment. So, okay, so this was how the astronomers understood about the expansion of the universe. Okay, now let's go and let's study about what happened exactly when these universe had started expansion. What exactly happened? Let's go and study this one. Okay. Yes. Let me share back the screen. Okay. So now this has been proved that the universe is not always the same. It was now see. Now we are talking about the Earth and Sun distance. It is like 150 million kilometers. But initially, when the universe was formed, sorry, when the solar system was formed, was this so close? Yes, definitely. The Earth and the Sun were close. As the universe is expanding, so they were moving apart. Okay, so if you consider each and everything, whatever galaxies which we consider, whatever stars which we consider, they were very close to each other when the universe was formed. Now the universe is evolving and it is expanding. So due to that, what's happening? These the distance between these objects, any object which you take, galaxies or stars, is also increasing. Okay. Yes. Next, a big bang was now most of the students, like the students of younger ages, now bang, when they hear a word called bang, now they think that so there was a big ball which is like a universe, and then it exploded, and then the entire universe started. Okay, so most of them think in that way, but actually it was not an explosion. The Big Bang was not at all an explosion. Okay, it is the inflation. Okay, starting from a tiny dot where there was immense, great energy, immense energy, and that energy could not tolerate the heat. And due to that, what happened? It started expanding. Now, it started expanding thoroughly, and then it moved from 0 years to 13.8 billion years. Okay, so this is how it was going continuously. Okay, so kindly note this one. The Big Bang is not any explosion. There was no explosion which have been done. Okay, like when you study about the black holes, when you know about the black holes, so everything, whatever the black hole sucks, will be going into a point called singularity, right? So similar to the same point, similar to the same thing, there is a singularity point in the universe. Okay, in the space there was a singularity point in the space. Okay, now that included quantum particles, okay, with very higher energy. And when these are very greater energy, now what happens? Now they'll be moving, right? They'll be moving very fast, so it cannot tolerate that heat. The temperature was something around 10 power 30 degrees. Like if you write any value like 1 or 2, and after that you have to write 30 zeros. So it should be Kelvin or it is degrees. So that hot it was. And immediately that singularity point could not afford that hotness, and then it started the inflation. And when it started the inflation, now the expansion of the universe had started like this. You can see, let us think that this is the starting point. Now it inflated, and then this was the second stage, this was the third stage. So space expands in this form. Okay. So it is not expanding by an explosion. Okay. Now, sometime in the past, now this white dot was a singularity which was extremely hot and so denser. Okay. Now it started its expansion. Now it became a bit hotter. It means that it is getting cool now. So when you supposing that if there are 50 students in the same class, if they are sitting 50 students in the same class, and if there are no fans, nothing, now how could you feel the temperature of that room will be so hot, right? This. So suddenly a 25 students came out. Now you will feel a bit relaxed, right? And then after that, 15 more came out. You will feel, okay, fine, this is so a bit very cool. Like when these compact objects, when they are very compactly packed, when they expand, when they start expand, they have a huge volume to cover the areas. Like they can take rest in a different portions, right? Now at this position, what happens as a space is expanding, the matter is also distributed evenly, like very far away from each other. So this is gradually cools down the temperature also. Okay. Now this point is a bit hotter point. Okay. This point is a bit hotter point. Now after that, this is a bit earlier point. Okay. This is a bit of earlier point. Next, long ago, this point. And finally, this is how we are watching it today. Okay. Yes. So I got a very good question. So how did we know that the universe has started 13.8 billion years ago? Okay. So this is the main task of the astronomers or the cosmologists who study this one. Right. So when we don't have any technology, when we didn't even take birth, the universe was entirely done. It's already completely prepared. Okay, now, but the light from the starting point, okay, the light from the starting point of that universe is still traveling in the space. And with the help of any sort of telescopes, if we are watching that light, okay, when JWST was recently launched in the year 2021, 1 year later or 1.5 year later, it could find a older galaxy which was one of the galaxies which formed during the formation of the universe, and they named it as a granny galaxy also, right? So the light reached us at that time. So this cosmologists do the same thing. They always go along with the study and they confirm when was that happened. Now, how did we know that solar system was formed only 4.5 years, billion years back? The same thing, a continuous study about that will give you this value. Okay. Yes. Now, so before when I was talking about these distances, I think that all these are the galaxies. All these colorful dots are the galaxies. Now think that this is how the galaxies are distributed when the universe was slowly expanding. When it formed, and after few years, like 300 million years or something else, there was the first star born, and then after that there were galaxies formed. When these galaxies were formed, when multiple galaxies were formed, they were very close to each other. Okay, when they were very close to each other. But now, what's happening now? The same dots are they in the same position? Are these in the same position? No, right? You can, if you can measure the distance between these two, it's like only 1 centimeter, like 1 or 2 centimeters, or else 5 centimeters. But here, if you can see it, it's more than 10 centimeters. Right? Now they are expanding. But actually, are these points expanding? Are these points moving apart from each other? Definitely not. The space is expanding. The space is expanding. The space which you can't see, the black color one, which you see over here, now that is expanding. And due to this, these dots also appear to move. Okay, now do one thing. If you have a elastic fabric, so there will be an elastic fabric. Normally we use it. Okay, a few of the students will have the stretchable cloths also, like stretchable kerchief or stretchable fans or something else. Okay, now on that, if you put two or three dots very close to each other and you stretch them, okay, and you stretch them. Now what will happen? Will the points be at the same where you have been placed? And will they be at the same distance when you have placed that? Definitely not, right? Because as the elastic expands, now the points also move out. They also move out from each other, right? They also move apart from each other. Now that is nothing but the elastic. The points are not moving. The elastic is moving. So this shows that the space is moving, not the objects. Think that the objects are also rotating and revolving, but the space is allowing them to move a bit faster, right? Due to that, the space appears to be, the universe appears as it is expanding so fastly. Okay? Yes, like this. If you take all these points here, A, B, C, D, E, F, G, H, I, and if you have a balloon like this, and then what you do, you are inflating the balloon now with the same points. Now you can see all these points are not at the same point now. They are at different points, right? They are separated by a greater distance. Initially, they are very close to each other. Okay, they were very close to each other initially, but now they are expanding. Now, are these points expanding? No, the balloon is inflating. The balloon is expanding. Okay, so this shows the universe is expanding rapidly. Okay, now what will we do is we'll take a small analogy here. Think that now this point is your reference frame. Okay, now A is your reference frame. Now, if you take this A point, okay, now if you take this A point as your reference frame and you are watching F, G, and H, okay, now are these at the same distance from the first and second balloons? Are these both at the same distance? No. So the farther objects, they appear to move very fastly. Like the closer ones, there is not much difference between these two, right? It can be a difference of 1 centimeter or 1.5 centimeter or 2 centimeters. But here there could be a difference of more than 5 centimeters. It means that an object which is a bit far away from you, it expands, it moves very faster. It is moving away from you with a greater speeds than the one which is closer to you. Okay, so supposing that there is a galaxy, Milky Way has a galaxy very close to it. Think that is Andromeda. Okay, and think that somewhere else in the space there is one more galaxy called Whirlpool Galaxy. Okay, that Whirlpool Galaxy is very far away from us. If the astronomers, if they watch Andromeda Galaxy and if they watch Whirlpool Galaxy at a time, so they will be confirming that Whirlpool Galaxy is moving with a greater speeds, whereas Andromeda is moving with a lesser speeds. But why is this case? The Andromeda Galaxy is very close to us, right? So that it appears to be moving away from us, but very slowly. They will be moving very slowly. But the Whirlpool Galaxy, which is like few light years away from us, when we watch it properly, so this shows that it will be going with a greater distances. Okay. Now, sir, you're telling about expansion. You're telling about why is this moving out? So everything is going out, but why, sir? What is this? Why is this moving? Okay. The universe is expanding just because of one thing. Okay, now that one thing is dark energy. Dark energy. So if you take about the entire universe, if you consider the entire universe, okay, if you consider the entire universe, 5% of the matter we know. Okay, what is the observable universe is only of 5%. 27% is the dark matter, which we cannot see, but it is present in between each and every object which we see. Okay, and the remaining 60 plus or 64 percentage of the matter is dark energy. Now, what is a dark energy? It is also a force of which force like gravitational force. Now, in the gravitational force, what happens when we are talking about the gravitational force? What happens there? So, it is a force of attraction between two bodies. Now, it tends to pull the objects very close, just like even the dark matter also does the same thing. Okay, so dark matter which is acting in between the two bodies, it is allowing them to come closer to each other. But dark energy is a repulsive force. It is a repulsive force. It repels out. Okay, whatever galaxy, supposing that there are two galaxies. Now it doesn't allow these galaxies to come closer. It is allowing them to move forward, move farther away from each other, move apart from each other. Now, this is how the universe is expanding. Okay, the universe is only expanding due to the presence of 60 plus percentage of dark energy in the universe. And this dark energy is nothing but a repulsive force, a repellent force, which doesn't attract the objects, it repels the object. And it tends the objects to go farther or apart from each other, not come closer to each other, apart from each other. Okay. Yes. So this is how it happens. Now, just let me. Yeah. Just give me a moment. Yes. Okay. Yes. So this is how the our universe looks like, and this is how the expansion is happening. Okay. Now, if you can see that it looks like a capsule, right? A medical capsule, right? Yes. Yeah. Okay. So at the initial point, there's points. There are few points over here, something like close to 7 points. Now see the first point over here. So this is the birth of the universe, which you're seeing is the birth of the universe. So this is the point where the entire energy, the entire quantum energy was concentrated, and this had a temperature which was close to 10 power 32 degrees. 10 power 32 degrees. Like so hot, and not even a star or anything can get that temperature. Okay. Now, what happened here? Due to that excess heat, the inflation started, the expansion started. And see how the expansion started. Initially, it was like very slow, very, very slow. And then suddenly it started expanding rapidly. Okay. As this was expanding rapidly, now this was the second stage. So, till here, the expansion was a bit of slow. Okay, a bit slow. It was still here, it was a bit slow. Now, here, that expansion started to expand in rapid way, very fastly. Okay. After this, the third point. Now, what happened in 1 second? In this third point, the cosmic background radiation. Okay. So, which was covering the entire previous universe. So this was the cosmic radiation, CMB, cosmic microwave background radiation. Now it started moving into the entire universe and making it so look so bright. Okay, and then we were able to detect the previous universe also in this light. So initially it was so dark. Okay, when this CMP expanded and spread out into the entire universe, previous universe, which was already been made as a point one and point two. So once this was done, we were able to see what was happening. Okay. Now, fourth point, here starts the major expansion and major creation of the universe is at this point. Okay. So here, all the elements like the stars, okay, and a few galaxies and the nuclear fusion reactions, everything started at this point. In the third point, there were the formation of protons, neutrons, electrons, and they combined to have an atom, and everything was made. Okay. So after this, there was one more point. Yes, 1 second. Yeah. Now, after one point, okay, after one point, after 1 billion year, then now what happened here? These first galaxies were formed. Okay, and after these galaxies, after these, all the galaxies were formed. I mean, like the older galaxies were formed. Now it is the time to for our Milky Way to take its formation. Okay, this formed at the fifth point. And after that, there were six and seven, where the entire universe is continuously expanding and formation of the solar system took place. And finally, now we are at the seventh point, which is the current expansion, 13.8 billion years, where the first humans were formed. Okay. Yes. Let me just go back. So, are we clear so far? Are we clear so far? Any doubts as of now? Yeah, okay, now I'll just give you a very interesting video and just watch this one and enjoy.